Welcome to The Explainer. Today, we're pulling back the curtain on a massive secret. The real reason machines can learn to read. From your phone's autocorrect all the way up to the most powerful AI, it all boils down to this hidden process that teaches computers our language. So let's dive in.
Seriously, just think about it for a second. How does your phone know what words you're about to type? Or when you ask a smart assistant a question, how does it actually get what you're saying? It feels like magic, right? Well, it's not. It's actually the result of this huge, invisible effort to teach machines all the rules, the patterns, and, the messy nuances of how we humans talk. And the foundation for all of this, we can think of it like a very special kind of digital library. But look, this is not just some random collection of files on a server. Oh no, this is a meticulously organized, you might even say hyper-intelligent library that's been built for one reason and one reason only: to train artificial intelligence.
So there's an official name for this process of building our super smart digital library. It's called Corpus building. And honestly, it's the first, and you could argue the most important step in teaching a machine to understand us at all. At its heart, corpus building is really just the big umbrella term for everything that goes into creating these organized piles of text. It's both a science and an art, gathering and structuring all this language data so that a machine can actually learn from it in a meaningful way. Now, it's really important to make a distinction here. On one hand, you could have just a text collection. Think of that like a giant, messy pile of books. It's just raw data. But a linguistic corpus, now that's different. That's our hyper-intelligent library. It's systematically put together, it's machine-readable, and, this is the most important part, it's been linguistically annotated. And that annotation, well, that's the secret sauce. We're going to get to that in just a minute.
So how do you even build one of these things? Well, it pretty much happens in two big stages. First up is the conceptual work. This is like the blueprinting phase. You got to decide, what's the point of this library? What kind of language should it have? How big does it need to be? Then, and only then, comes the practical part, the actual construction. And that means going out, finding the right texts, scanning them, digitizing them, and encoding everything in a standardized way. Okay, so that brings us to a really key question. Why? Why go to all this trouble? What's the ultimate goal of building these massive, incredibly complex digital libraries? Well, the reasons are actually pretty diverse. A corpus could be the absolute bedrock for academic research, helping linguists find hidden patterns in how we speak. Or it could be built to answer a very specific question, like, how has the English language changed in the last 100 years? Sometimes the goal is way broader, just to capture the true diversity of a language, or even to preserve a culture's entire literary history. In every single one of these cases, by organizing our language this way, we're creating a powerful tool for understanding ourselves. All right, so we've got the library structure down, but what about its superpower? The real magic, the thing that turns a simple collection of words into an intelligent resource for an AI, that process is called annotation. Annotation, you might also hear it called tagging, is basically the process of adding layers of linguistic information right on top of the raw text. So it's not just about the words themselves anymore. It's about creating an explicit record of their grammar, their meaning, their relationships to other words. It's kind of like adding super detailed footnotes to every single word for the machine to read. Okay, let's see this in action. Here's a simple sentence. To you and me, this is a piece of cake. We get it instantly. But to a computer, this is just a string of characters. It has zero built-in meaning. The very first thing you do in annotation is a step called tokenization. We just break the sentence down into its smallest meaningful parts, or tokens. So in this case, each word becomes its own distinct token. This gives us the basic framework we're going to build on. Now, we add another layer of intelligence. This is called part of speech, or POS tagging. Each token now gets a tag telling the computer its grammatical job. So the is a determiner, smart is an adjective, fox is a noun, and sees is a verb. And just like that, the machine doesn't just see a random string of words anymore. It sees the structure of the sentence. It's starting to understand that some words describe things and other words show action. It's a huge leap.
And believe me, this is just the beginning. Higher-level annotation can start to identify people and places. That's called named entity recognition. It can map out the entire grammatical tree of a sentence, which is called parsing. It can even start to tag for semantic meaning. Every single layer adds more intelligence, making the text richer and way more useful for an AI. Okay, this all sounds incredibly complicated because it is, which raises the question, who's actually doing all this work? Who are these librarians of the new digital age, meticulously tagging every single word? Well, there are a few ways to go about it. You could do it all by hand with human experts. That's going to be super accurate, but it's also incredibly slow and costs a fortune. On the other end of the spectrum, you can try to automate the whole thing. That's fast and it's cheap, but the accuracy, it can be a little all over the place, especially when you're dealing with tricky language. And that leads us to the real hero of our story today, the human-in-the-loop system. This is a hybrid approach. You have an automated system do the first pass, the heavy lifting, and then human experts jump in to review, correct, and refine what the machine did. It combines the raw speed of machines with the crucial wisdom of people. Because, let's face it, an AI might miss sarcasm or not get a cultural reference. It takes a human to catch that stuff. It really is the best of both worlds. So, the next time your phone perfectly finishes your sentence, just remember that invisible library working behind the scenes and the human experts who are teaching machines one word at a time what our language actually means. And this leaves us with a pretty big question to think about. As AI reads more and more of our world, who are the people building its understanding? And who really gets the final say on what a piece of text truly means?